Okay, good day, students. It's been a while since we've had a video, so I hope you enjoy. We're going to be covering, for the most part, objectives 2 and 3. How do we convert to grams and liters using moles and vice versa?
Hana Bang and Fujian Bang, please.
Okay, we totally took a pause there for a second. Okay, so the first thing that we're going to do is you're actually going to go to your reference page because we're going to add some information on your reference page. So the first thing that we want you to do, and I'm going to put down pencil, okay, and we'll go ahead and do black, is that there are a couple things. First is diatomic molecules. These are special elements that actually exist as more than one when they're by themselves. So we're just going to make sure that we have a list here for you. Hydrogen, looks like that, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. For this unit, we'll actually make sure we give those formulas to you, but as we get further, you're going to have to make sure that you start to memorize those. They're pretty easy. We also call them like a Han7, so those should be really easy to remember. So make sure you have that on the reference page. I'm going to actually erase and do again some more information. So make sure that you've paused if for some reason that wasn't long enough. So a couple of things that we're going to write down is STP. If you haven't heard of that before, and this is new, it stands for standard temperature and pressure. So you want to write that down, standard temperature and pressure. Temperature and pressure. Okay, and we also want to make sure we give you those conditions. In this particular unit, we're going to only use standard temperature pressure, but in a couple of units, we'll address what happens when we're not at standard temperature and pressure. Standard pressure in terms of this, 1 atm, and then standard temperature is known as 0 degrees Celsius or otherwise 273 Kelvin. So we are dealing with gases, so the Kelvin becomes important. And one last thing that you are going to put on your reference page is, this is on your sheet as well, but you probably want to write down this idea of the mole is equal to the molar mass, where you get from the periodic table. Sorry, made a mistake there. Just going to erase that whole one. And I'll put molar mass. Molar mass. And this comes from the periodic table. That's that bottom number. You guys had a ton of practice with that. Oops. You're seeing lots of nice confusing mistakes here. Okay, periodic table. And something that is new is that we now know that 1 mole of any gas, this is through Avogadro, is 22.4 liters at STP. Okay, so you want to make sure those are on your reference page, and then we will move and make sure you grab your sheets for your notes. We're going to take a short break and come back. Okay, well, welcome back. Sorry for that pause. You want to go to page 57 in your notebook, and I'm going to refer back to the essential question. This should go on the top of that page. How do we convert grams to liters using moles, and vice versa, if you want to add that. And you should have grabbed a little half sheet that you would be answering these, so you do not have to completely write them down on your own. So we're going to skip over the reference page stuff. I'm actually going to erase that. Oh, erase the whole thing. Okay, and we're going to go to our problem. So this should be question number 1 on your sheet. So we're going to look at that. How many moles of calcium nitride are in 2.56 grams of calcium nitride? So what we have right now is that you are trying to figure out how many moles. Okay, so that's our unknown. And you are given grams. So the only thing at this point that we know that converts from grams to moles is the molar mass. So right away, knowing that you have mass in moles, you can go ahead right away and figure out what the molar mass is. So 1 mole of this Ca3N2 is equal to, there's 3 Cas, and the mass of Ca is 40.08 grams. Okay, and you're going to add the 2 nitrogen, which is 14.01 grams. Again, it's grams per mole, but we put moles over here. And so the answer you get is, I'm going to put that into my calculator, 3 times 40.08 plus 28.02, you will get 148.26. At this point, grams of Ca3N2 was 1 mole. At this point, we are not asking you about molar mass, but you do need molar mass. So this work is not required, but we're just showing you that work in order for you to see where we're getting those numbers from. You notice how I took this grams per mole thing and turned it into this unit conversion that we had at the beginning of the year with density. So you're going to start with the number that you're given. So we're going to start with 2.56 grams. Super important that you're starting to write the substance down as well as the units. You can put it over 1 if that helps you remember that it is on top. So we're trying to cancel out this unit. So we know that that unit has to go on to the bottom. And please note that I am putting the units in first. Again, you don't know what the numbers is until you know what both units are. So because I'm looking for moles, I know that I can go from grams to moles using this. I'm going to put my moles on top. Moles of Ca3N2. Then I'm going to go ahead and plug in my numbers. I know that 1 goes with mole, and I know that 148.26 goes with grams. I'm going to plug it into my calculator. 2.56 times 1 divided by 148.26. 2.56 divided by 148.26. Moles tend to be a relatively small number, so don't be surprised if you have a small number. 0.0173. I rounded it. Moles. Again, making sure I label. The numbers you round to, you really won't. I'll typically round to 3. I use the correct rules for rounding. We didn't go through those and hold you accountable to them, so something close to that. So keep that in mind. So hopefully that made sense. So this one was going from grams to moles. Okay. So I'm going to actually enlarge it for you quick if you want to see it. Maybe. Sorry, I'm having trouble with the pen. Maybe I'm not going to enlarge it because I can't get to the screen. Okay, so I guess I am not enlarging that for you. Okay, so make sure you pause if you didn't get all this because I am going to go ahead and move to the next one. Okay. So the next question is looking specifically at the opposite. How many grams is what we're looking for of 1.84 moles. So the nice part about this is that we have a single element, so we don't have to do any calculations for molar mass. But what we do know is 1 mole of sodium from the periodic table has 23.00 grams of sodium in it. So we will need to use that as our conversion factor. So again, you start with the number that's given to you, 1.84 moles sodium. You'll notice yet again, I'm going to put it over 1 in case that makes you feel better. Trying to get rid of moles, you notice this time moles is on the bottom because that's what we're trying to cancel out. And then I can put grams on top. Okay, so those cancel out. I didn't do that last time, sorry. The number that goes with moles is 1, and the number that goes grams was 23.00. So I plug that into my calculator, run out of space there, so I put it underneath. 1.84 times 23. And I'm going to get 42.32 grams of Na. That would be my answer. Okay. So hopefully this is going smoothly. It's coming back to when we were using density of the differences. Instead of using grams and liters, we're using grams and mole in this particular case. So these were our mass problems. Now we're going to go ahead and try some volume problems. Pause for a second. Okay. So again, if you are not quite done, please feel free to pause this to make sure you write those down. But we are going to move on to question number 3. So question number 3 now deals with something different. How many liters, moving slow, so we're looking for liters, are in 9.35 moles. So from the beginning of the sheet and on your reference page, you should have seen this, that 1 mole is equal to 22.4 liters. Again, this is of a gas at STP. We will only be looking at liters of a gas at STP, so you don't have to worry about us tricking you there. So similar to the math, you're going to start out with your 9.35 moles. Again, make sure you're putting the substance. Oops. Okay. You may be asking, do I have to do it in dimensional analysis? You do have to do it in dimensional analysis, okay, because that's, again, what we're looking at. So we're looking at moles of CO2 to be canceled out, so we're going to put moles of CO2 here. And then the question is looking for liters, and since I have this conversion, I know that I can put liters of CO2 on top. So now I'm going to go put the numbers in. The number 1 goes with the CO2, and the number 22.4 goes with liters. So now I simply plug that number in. If you can look at it, it's probably going to be a pretty large number because it's got lots of moles. We're going to end up with 200, I'm going to round it to the whole, 8 liters of CO2. So that's our answer. So the next question we would like you to try on your own. So if you go to question number 4, okay, how many moles of oxygen gas, O2, are in 3.5 liters of oxygen gas at STP? So we gave you the answer right here. So you go ahead and try that on your own and see if you got the answer. If you are struggling at all, your teachers are there to answer any questions, and feel free to ask them. And then we'll move to a little bit more difficult one. Okay, so hopefully you had figured that out all on your own. Now we're going to try one of the trickier ones that requires 2 steps, and then you will do one of those on your own as well. So again, we are on question number 5 at this point. If you could look at that, we're looking for how many liters are produced at STP if there are 23.8 grams. So you notice at this point there are no moles. However, we need moles. So we know that 1 mole of CO2, sorry. And then we're going to figure out the molar mass. So carbon is 12.01. There are 2 oxygens, so that's 16 plus 16, which is 32, which gives the molar mass of 44.01 grams for CO2. We also know that 1 mole of CO2 at STP is equal to 22.4 liters. Okay, so now let's try the problem. So again, our given is 23 point. Ignore that.
Room 1037. Fu Vang, please come to room 1037.
Okay, 23.8. So we're going to start out with our 23.8 grams of CO2. We're going to try to cancel out that. Again, if it makes you feel better, put it over 1 grams of CO2. We're going to, again, put only units in first. Looking at our conversions, when we have grams, the only thing we can go to is moles. So we're going to put moles of CO2 on the top. Since the question is not looking for moles and it's looking for liters, it's telling us we are not done. So we're going to do one more step. Okay, we need to get rid of moles of CO2. So that's going to go on the bottom. And I can go, now that I have moles, I can either go to grams, which doesn't make any sense, or I can go to liters, which does make sense. So I'm going to put liters of CO2 on top. Now I'm going to put the numbers in. I know the number 1 goes with moles, and 44.01 goes with grams. I know that 1 goes with moles here, and 22.4 liters goes there. So now I plug this in by taking 23.8 times 1 divided by 44.01 times 22.4 divided by 1. So my answer is 12.1 liters of CO2. So it's a little bit trickier because it's got 2 steps. So now we're going to have you try your 2 steps on your own. So if you go to question number 6, try that on your own, but here is the answer. So the answer for number 6 would be 2.07 liters of NO2. Again, if you have any questions, make sure that you are asking your teachers. Hope this is helpful.